Welcome, friends, to another session of the Kubernetes Fundamentals series. This is session number 13. And today I'm going to talk about DaemonSets and jobs. Is that DaemonSets or DaemonSets? So you can pronounce it as both of them, I guess. So I'm going to say DaemonSets or DaemonSets, okay? So let's get started, okay? DaemonSets are used for applications that you want to run on each of the nodes in the cluster, okay? Maybe you have a logging application, or maybe you have, I don't know, maybe a security enforcement kind of application that you want to run on each of the nodes that are in your cluster. So that's why you can use DaemonSets, okay? They ensure that a specific pod runs on all or a subset of nodes in a cluster, okay? That's the gist of DaemonSets. And actually, a lot of applications that you can install nowadays in your Kubernetes clusters are running as DaemonSets. For instance, log collection is one of the examples that most of the time is using this kind of resources. So DaemonSets are part of the apps/v1 API version kind of resources. And the kind is DaemonSet, as you can see here. So it has API version, kind, metadata, and also the spec. This is very similar to a deployment if you think about it, because you have a selector, which is match labels kind of selector, and then you have the pod template, okay? So inside the template, you specify the pod. In the selector, you specify, of course, the selection of those pods that are going to be considered in this DaemonSet. In the metadata, you can specify the name and also labels or annotations or what have you, and API version and kind, okay? So the difference here is, of course, kind, and also we can use tolerations, which is a way of telling Kubernetes, hey, you know what? I want to run this pod that has this container or this number of containers, and I want you to bypass, or I want you to tolerate some restrictions on the nodes. For instance, there are some nodes that could have taints, which is the technical name for that. And taints tell the scheduler, hey, you know what? I don't want this and this and this other kind of pods or applications or objects in this node. So it's a way to prevent the scheduler for scheduling things in those nodes. And tolerations is a way for Kubernetes to bypass those restrictions, okay? Actually, I'm not going to talk about tolerations and taints. That's the topic for another session. But yeah, you can use tolerations, and most of the time you want to do that in your DaemonSets if you want to bypass the taints, okay? So let's create our first DaemonSet. So I'm going to open up my terminal, and let's see what's going on here. So kubectl. So first, let me see if I have Minikube. Is it running? Minikube status, remember that I'm using throughout the series, I've been using Minikube. So yeah, it looks like it's working, and I have 3 nodes, okay? Actually, this Minikube in this laptop, I'm not using my desktop PC. This laptop, I'm using Minikube on top of Docker for Windows. So this is another driver that Minikube supports. I'm not using the Hyper-V version of Minikube, okay? So I have 3 nodes. Let's verify that this is running. Cluster info So it looks like it's running. So kubectl, you know what? Let me create an alias K. Is that PC? Is that PA? Is set alias? Is that the name? Or alias? I can't remember the commandlet. PA say. Anyways, I'm gonna just write kubectl. I don't care. So let's create DaemonSets as a folder. DaemonSets. In here, let's kubectl get all, just to understand what's going on here. Okay. I have a deployment, I have a service, I have other things that I've been using for some training purposes. So I don't care about those. Let's see if I have a daemon set, get daemon set. I don't have any kind of daemon set, so that's fine. Let me show you one thing, okay? API resources. Remember that you can use this command for displaying all the different objects that your current Kubernetes version supports. So in this case, I have daemon sets. It should be right there. It should be right here. Okay, daemon sets. And the short name is DS. So in other words, I can say kubectl get DS. And of course, I don't have any kind of daemon set in this moment. So I can create a daemon set using the imperative way by using create DS and then the name, right? My daemon set or something like this, right? And then outputting this to YAML. However, let me use Visual Studio Code because I guess it's better for these sessions instead of me creating those objects by using the imperative way and using output the YAML and then changing things. Let's just use the Visual Studio Code extension, DaemonSet.yaml. Okay, so DaemonSet, do I have a template for DaemonSets? That's the question here. DaemonSet, no, I don't. So I'm gonna just copy this, okay? And I'm gonna copy the pod spec as well, okay? So of course the spec, this is the spec for the pod. So it should be right here. Let me zoom in, right? So the spec is part of the template, and this is the place where we specify the pod. Let me open up my, what's the name of this? Epic Pen. Do I have Epic Pen in this laptop? Yes, I don't. I guess my laptop doesn't have all the tools that I have on my desktop PC. If you've been following this series, most of the time I'm in my desktop PC. Anyway, so it looks good. This is my daemon set, all regular things, API version, kind, metadata. Remember that the kind is daemon set. And inside the spec, we have the selector. Be careful because this label, in this case, app, that's the name of the label. That's just a random thing that this Visual Studio Code extension created, but it could be any kind of label that you want. This should match the labels of the pod that you want to run as a daemon set. Makes sense, right? It's just like a regular deployment. So we have the selector and then the template. This is a place where we define the pod. And in this case, this is going to use Nginx. I just want to use the latest version of Nginx, okay? And I want to expose port 80 through TCP. And toleration, this toleration is telling Kubernetes, specifically the scheduler, hey, you know what? Let's bypass that restriction, that taint that the master node has, right? Of course, it depends on your Kubernetes installation. In this case, this toleration obviously is for the master node, and that master node should have that taint in order this to work. Anyways, looks like for this specific demo, the toleration is not needed. However, I'm gonna leave that there, okay? Let me fix this so it looks nicer. Okay, so looking good. Kubectl apply my daemon set. Is that the name? Yes. Do this, okay? Daemon set created. So I can say kubectl get daemon sets. So as you can see, I have my daemon set running in this moment. It says, okay, my daemon sets are running. Why is that? Because I have 3 nodes, right? Get nodes. I showed you that when I executed Minikube status. So I deployed Minikube in this laptop by using the Docker for Windows driver, and I created 3 nodes, okay? So technically speaking, those nodes are running as Docker containers in this laptop. This is a great way for us to test Kubernetes and play with this technology. So I have 3 nodes, and the daemon set is running in all of those nodes, okay? So pretty easy stuff. So actually, let me describe my daemon set, okay? So as you can see here, we can, let me clear the screen and execute this again. So again, I can see that the desired number of nodes is 3, and the current number of nodes are 3, okay? So I can see that this is running correctly. And of course, it's running Nginx. It's not doing anything special right now. It could be using any kind of application, or it could be using, I don't know, the BusyBox container image for executing any kind of bash command in each of those nodes, okay? So, and yeah, the taint, we can see that, not the taint, the toleration worked because it's bypassing that taint. You know what? Let me show you that. Kubectl get nodes, okay? I have the Minikube node, which is my control plane node. Kubectl describe node Minikube, okay? So let me show you that I have, do I have taints here? I should see the taints in this describe taints. Okay, so there are no taints. In Minikube, there are no taints at all. However, for all of those nodes that do have taints, this is a place where you can list them, okay? This is the place where you're going to see them. In this case, Minikube didn't add any kind of taint in this code, in this node, okay? Anyways, so the toleration at the end of the day, I could remove it and the result will be the same, okay? Okay, so that's daemon sets. Let's continue with the presentation. Okay, cool. Jobs. So jobs, they allowed you to run a task or batch process that runs until completion, okay? And this is useful for, I don't know, maybe something that you need to run, and you want to be sure that that task completes successfully, okay? That's the use case for jobs. So they're useful for tasks that need to run only once or a specific number of times, and that they guarantee that the desired number of successful completions will be achieved. Okay, so jobs are quite useful in that sense. There are some use cases for using those, such as batch processing. I mean, you can be running jobs all the time for doing some kind of process or task, database migrations for running database migration and creation of schemas or schema validations and those kind of things. Data backups, if you want to regularly say you need to back up a special folder or a special storage that is running in your node, you can be running this job, and that job could be doing your backup. Machine learning, of course, you could be running machine learning training jobs in a node, and you want to fire up this kind of processes and let them finish and schedule tasks. I'm going to talk about that when I talk about cron jobs in a few minutes, okay? So one of the, or some key fields for jobs are the ones that I have here in the screen. Completions, it's the number of times a job's pod needs to run successfully to be considered complete. So that's just a field that you set. I'm going to show you that in a few minutes. You can set this field, completions, and the number of completions that you want, so the job executes that number of times to be considered complete and successful. Parallelism is the number of pods that can run simultaneously. So this is useful for machine learning. Again, if you want to execute, I don't know, machine learning models, training, you could be running those in parallel instead of just waiting for a job to complete and then another job to complete. So this is useful for not waiting for a previous jobs to end. Backup limit is the number of times Kubernetes will retry a job if it fails. So the default, I think it's 6. So 6 times it's gonna wait and it's gonna retry before Kubernetes says, you know what, this job is not working. This is not working. I'm not going to retry anymore. So you can set this backup limit field as the number of times that you want, okay? So yeah, the default is 6. So here's the manifest. Here's the manifest. So as you can see, the API version is batch/v1. This is a different API version. And this is because jobs were created after a lot of the primitive resources that we've been talking about in this series. And the kind is job, okay? Pretty easy stuff. Just remember the API version, kind, job, metadata, just as usual, and the spec, again, as usual. And inside the template, just as you expect, is the place where you define the pod, okay? So inside the spec of this pod, we have, in this particular example, it's gonna run busybox, and it's gonna run this particular command, which is shell, and it's echoing hello world, and it's sleeping for 30 seconds. Pretty easy stuff, actually, this particular example. However, one of the things that I want to highlight here is that restart policy is set to never. This is because restart policy, the default value is always. That means that if your pod completes, the pod itself is going to be restarted, and you don't want to do that, right? You want the job, and the pod to execute and not restart once it's completed, okay? So that's why you can use restart policy and use the never value to prevent that. So in this case, container won't be restarted if it fails or completes. That's actually very useful for these jobs, okay? And as I said, backup limit, that's the property that you can use to set the number of retries before marking the job as failed. So again, the default is 6. You can set it as any number you like. Completions is the number of completions that should be complete, right? In order to this job be considered as successful. Parallelism, that's the one that I told you about. This is the number of pods that will run at a time. And TTL, seconds after finished, this is interesting because if you're running jobs, mostly cron jobs, you don't want your cluster to be full of jobs and jobs and jobs and jobs that have completed. You know what I mean? You don't want to keep those finished jobs all the time, right? Until the end of time. So maybe you want to delete those. That's why TTL, seconds after finished, it's particularly helpful for deleting the jobs after they complete, okay? After, in this case, 10 seconds, for instance, if the job completes, then after 10 seconds, it's going to be deleted, okay? So let's do this. Cool. Let's do this. My job demo. Let's see if I have, yeah, I have a template here in Visual Studio Code. So API version is batch v1. The name is my job. Release stuff. Let me change this to this other place. Okay. So in this case, the Visual Studio Code extension is using Perl, and it's running this Perl command. Okay. I don't want to do that. Let's do the busybox example. Busybox, command, shell, and that's going to be -c, and let's echo hello C#Corner this, and let's, I don't know, sleep for 30 seconds or 60 seconds is fine. So restart policy set as never. That's one of the things that I just mentioned. And this is the number of seconds that is going to wait for the job to be deleted. So that's fine. 100 seconds is almost a couple of minutes. And let's do this, okay? Completions 2. Okay, let's begin by using just one completion. It's fine, okay? Okay, so DaemonSets, actually, this is a folder that I'm using today, and I created the job inside this folder. Anyways, kubectl, apply, my job. Do I have jobs? Let me show you the kubectl API resources again. Let me try this again, okay? Jobs, it's right here, okay? So there's no short form for a job because it's short, right? Itself, it's just a 3-letter word. Anyways, kubectl apply f my job. So the job is created. We can query for those jobs. Job kubectl get job. I'm trying to use the K alias. So my job, right at this moment, it doesn't have any completions, right? Let me watch this. Because the command itself is echoing hello world, hello CSharpCorner, right? And then it's waiting, is that 60 seconds? Yeah, it's gonna wait for 60 seconds. So in this moment, the job is running, right? It's doing something, it's processing the task, it's training the machine learning model or what have you, right? Of course, in this case, it's just echoing that string and it's waiting for 60 seconds. But this is on purpose, okay? Because I want to show you that this job is going to take 1 minute, right? And after a while, after that minute, the job will be completed, okay? So we can see here in the completions column that the job is completed. It's a good job. So we have my job and number of completions. One of them were expected, right? This is the desired and the current. So we have current and desired. Right now, those are the same. And of course, the job is considered complete, right? It took 68 seconds. And actually, I think that's the information that we have here. And we have some other things, such as what was the container that this job was using, and the selector itself. So let's query for the job again, because after 100 seconds, the job will be deleted. Remember that? That's because of the TTL seconds after finished. This one that is right here. Okay. So after 100 seconds, this job will be deleted automatically by Kubernetes, which is great. This is very useful to avoid having hundreds or thousands of jobs in your cluster, okay? So let's wait for this to be deleted. I guess it was deleted already, yeah? So the job, we don't have any other jobs, right? That job was deleted. Great, so let's try completions. So let's do this shorter, okay? So completions, let's try 2, okay? And let's try this again. Let's go back here. Kubectl apply, kubectl get jobs. Okay, let's watch this. So the first completion is running, right? I mean, the first process, right? The first job, the first task is running. So that's gonna take 30 seconds or so. And then the second completion will run, okay? Well, as you can see here in the column, we have the desired number of completions and the current number of completions. Right at this moment, we have 1 completion. The job is still running. It's not complete, okay? It's not complete because it's waiting for the second completion to be done. Make sense? Pretty fantastic example and a useful object, right? This job is. So this is going to take another 30 seconds. And yeah, the job is completed. So after 1 minute, that job will be deleted. Okay, so I'm not going to wait for that. That's going to happen. And of course, backup limit. this is useful for retrying, because what happens if your container fails somehow, right? Of course, busy bugs, it's not going to fail. I mean, it's just echoing. But I could create a command for randomly sending errors or something, and that's where the backup limit field comes in handy. Okay. And finally, parallelism is the number of jobs that will run at the same time. So let's explain cron jobs, which is, I think this is an abstraction on top of jobs, because those jobs, the job that I created, I run the job manually, right? I applied the manifest. So I decided manually, to run the job. That was deliberately executed by me, right? So most of the time, you want those jobs to be executed on a schedule, okay? That's where cron jobs are useful, okay? Those cron jobs are built on top of jobs and are used for running periodic tasks at scheduled intervals. So in other words, you're gonna schedule a particular task to be executed and let Kubernetes do the job and just report if the job was successful or not, right? That's a cron job. So the cron job creates jobs, okay? The cron job, you set the schedule. I'm going to show you this. You create the schedule. You define, I want this, I don't know, I want this job to run every 1 hour or every day at 10 p.m. or those things. And the cron job itself is going to create jobs, okay? The cron job is going to create job objects, okay? And of course, job objects themselves, they have pods, okay? So we have the cron job manifest right here. The most important thing here is the schedule. To be honest, this is the trickiest thing about cron jobs. The cron expression that is right here, okay, that you use in the schedule field. This is the most complicated thing about cron jobs. You have to know the cron expression, and you need to read it and understand what's going on there. Of course, if you understand cron expressions, you're fine. Otherwise, you can just read the documentation and that's it. But actually, if you see this, if this is your first time reading cron expressions, you will be like scared, right? Anyways, this cron expression that is right here, it has minutes, hours, seconds, minutes, hours, and I think this is the day of the month, and this other one is the day of the week, or the other way around. We can see the documentation, but actually it's not necessary. And inside the job template, you specify the job, right? And inside the job, you specify the pod. That's why we have spec that is inside this other spec, right? And this spec is inside this other spec. Be careful about that, because this is not clean, to be honest. This is tricky. But anyways, this is the way that we define cron jobs. So let's do this. My cron job, YAML cron. Do I have a cron job? Oh, no, I don't. I don't care. I can just copy this and show you this, okay? So API version is batch /v1, just like a regular job, okay? The kind is cron job. Let me show you the API resources command, kubectl API resources. So the short name is CJ, okay? CJ. And metadata, API version, kind, metadata, and spec, regular things, right? Inside metadata, you can define the name for this object, which is the cron job. And then inside the spec, you define the schedule. That's the most important thing here. So this schedule, it has a cron expression. Let's see if I can execute kubectl explain cron job dot spec dot at the schedule. Yeah, explain cron job spec schedule. Thank you, Kubernetes documentation. It's not telling me anything. It's sending me to Wikipedia. Anyways, that's seconds, minutes, hours, the day of the month, and the day of the week. But you can always go to the Kubernetes official documentation. So if this is true, this will run every 1 second, okay? And this will run every 10 seconds. Okay? Let's see that. Let's verify if this is going to work. And then job template, okay? Job template, and you begin specifying the job template. And here, right here, you can begin specifying the different properties for the job, not the cron job, okay? The job itself. For instance, TTL seconds after finished, and let's do 20. Okay. So again, job template, those are the properties for the job. And then it comes the spec, which is the pod itself. So we have the template, and inside this spec, we can define the pod specification. And there's the place where we can define the containers and volumes and those kind of things. So in this case, it's running busybox. In this other case, it's gonna say hello world, and it's going to say the date. And the restart policy that I'm using here is on failure. I changed this to be sure that this process will run successfully. And if that happens, then the job will be considered completed. And then the cron job will be considered successful. Do you see that relationship, that inheritance between pods, jobs, and cron jobs? So it's kind of tricky to have 3 specs, one inside the other. However, if you think about it, it makes sense. I don't like the syntax, but it is what it is right now. Okay. Okay, cool. So it makes sense. I guess this is enough for us to test this. So I have my cron job. By the way, if I execute get jobs, do you remember that the previous job was waiting for, I guess, 1 minute or something to be deleted? So we have no jobs at all. So it makes sense. Actually, let's see if something happened. Let's see if we can see something here. Yeah, created pod, job completed, right? I'm executing kubectl get events to obtain the events from the cluster. Anyways, kubectl apply f my cron job. So cron job version v1 cannot be handled strictly calling no field spec job template TTL seconds after finished. So it looks like something's wrong. So this should be here, I guess. TTL seconds after finished. Is that it? TTL seconds after finished. Is that the error? So it looks like something's wrong. Kubectl explain cron job spec and then job template. Okay. Okay, job template has the spec, and this is a job object. TTL seconds after finished, so it should be inside the spec. And of course, my YAML syntax is wrong. That's why. Okay, right? This syntax doesn't make sense. I'm sorry about that. And actually, the Visual Studio Code was telling me, hey, you know what? This is not wrong. I mean, this is not right. TTL seconds after finished should be inside the spec. Thank you, Kubectl explain. Let's apply this. And now the cron job was created, get cron jobs. So this one is supposed to run each 10 seconds. Let's see what's going on here. Is that seconds or maybe 10? The first one is minutes, hours, days. I'm not sure. Let's see this, okay? So Kubernetes.io and cron expressions. Let's see if I can find the meaning of the cron. Okay, so the first one is minute, is not seconds. Okay, hour, day of the month, day of the week. That's actually the meaning of those. So I don't want to wait for 10 minutes. Let's delete this cron job, delete cron job, example cron job. And let's edit this. Okay. And now let's apply this again. Kubectl get cron jobs. So this is gonna run every minute. So we have to wait for this to run. And yeah, actually, let me show you other thing, which is the number of jobs. I don't have jobs that are running right now. So this job, this example cron job, I don't know if it came from this cron job. So let's wait for this to be to run, okay? And that cron job is going to create a job, and the job itself is going to wait for the pods to be completed, okay? Anyways, let's wait for this, and let's see if I have more information about this. I don't think so. Let me show you the blue labels that I have here. So this is the cron expression. This is the inner job template. And then the inner pod template. Okay, makes sense? So let's go back here. So yeah, I think run. You know what? Let me again kubectl delete cron job. My example is that cron job. Then kubectl get cron jobs. And kubectl get jobs. So I don't have cron jobs. I don't have jobs. That's fine. Let's apply this. kubectl get cron jobs and jobs. Jobs. Job. And jobs. So this is the job that is going to be executed by the cron job. And yeah, I mean, I have to wait for this minute to pass to see that the job was completed. Okay. I think the previous job that we were seeing there, I'm not sure if I didn't delete the cron job correctly. Anyways, this cron job is right there waiting to execute. Let's wait for 20 more seconds. And then this job will execute again. I mean, I think that was executed and then it was deleted, right? So let's wait for this. Maybe things are happening faster than my hands. That's why, right? The cron job creates the job, executes the job, and then waits for 10 seconds to be deleted, and then waits for 1 minute to run again. Maybe that's what's happening here. So I have the job, it was completed. So yeah, things are happening very fast. So this job was deleted because of the TTL after finished, TTL seconds after finished value. Maybe if I remove that, kubectl delete cron job, example cron job. I shouldn't have cron jobs, neither jobs. Let's remove this. It has 20 seconds. Anyways, let's remove this because otherwise this is going to be confusing. Let's try this again. Cron job, kubectl get cron job, have the cron job, and of course, I don't have any job right now, okay? So let's wait for this to be finished, and then it's gonna create the job. The job will wait for the process, and the job will not be deleted, okay? So I have to wait for this, so let's just watch the jobs to be created. Anyways, as you can see here, the cron job is useful for scheduling things. Of course, this is just doing echo and blah, blah, blah. It's not very useful. I mean, the command is not doing anything fancy right now. It's just creating those jobs, and I'm just describing the way cron jobs and jobs work, okay? So that's great. The job was completed. It's right there. It's not going to be deleted. So we can get a grasp about how things work. Anyways, very useful stuff for Kubernetes applications to have DaemonSets, jobs, and cron jobs. I think from those three, I think the most useful is the DaemonSet, and of course the cron job. The job manually firing things, I mean, it's good to have the option. However, I think jobs are mostly used by cron jobs. And yeah, take care about the schedule. As you can see, I was struggling with the syntax of the cron expression because I don't remember the 5 positions that it has. And there are some cron expressions that have 6 positions. I don't know why Kubernetes decided to use the cron job expression, the cron expression with 5 positions instead of 6. Anyways, be careful about those cron expressions. That's actually the most tricky part of cron jobs. And with that, that's all I have for today. And thank you for your time, and see you in the next session where we're going to talk about Ingress. Okay, take care.